Okay, lesson 5. Okay, now we're doing what's called composition of functions. So now we're putting functions inside of functions. Okay? And with that comes the whole kind of, when you get the final answer, is that domain and range, do we just look at the final answer? And you could probably guess, no. Okay, it's kind of like when we did non-permissibles, you just don't look at the final answer. You got to look at the non-permissibles all the way through. If it's not allowed over there in step 1, it's not allowed ever. Okay? But let's start dealing with just a good composite function here. And here's a word problem. Now, this is something that I could see, you know, if you're studying for a test, you have to think about, well, what would be on that test, right? Well, a composition function will be one of these, I think. They're going to put a word problem on there. And you're going to see how they work as we go through this, and you'll do a couple in your homework. So we have a 3.5 liter V6 2012 Toyota Camry. Does anyone understand why those numbers are in there? They do want to get you, see, can you take some numbers away that are irrelevant, okay? And that's, I mean, they call them problems for a reason, right? Because they're a problem, right? And why do we have problems with these? How do you get, like, just give me the formula already, you know? Just give me the math, right? Well, obviously, these don't do that for you, right? You got to read, you got to assume a couple things, all that stuff. But this is good stuff to kind of get rid of. Okay, whenever you're starting with problem solving with students, you teach them how to get rid of, I don't know, irrelevant information, right? So just a car, okay? A car has a fuel efficiency of approximately 8.2 liters per 100 kilometers. The cost of gasoline is $1.25 per liter. Now, I'll give you a tip right now. 8.2 over 100 is basically not a very nice fraction to deal with, right? But we want to make this called a unit rate. Like how much is it for like how many liters for 1 kilometer? And that would be 0.082 liters per kilometer, right? I'll use a small L. And this is actually how, if you ever watch, I watch a lot of like car shows because I enjoy that kind of stuff. The U.S. is always miles to the gallon. You always hear miles to the gallon. Well, in Canada they always say 2.6, or actually no, that's pretty good. 4.8 liters per kilometer, right? And to me, like because I've always been miles to the gallon, right? But Canadian magazines and Canadian car shows always say the amount of liters per 100 kilometers. Okay? And you got to think of a liter, right? Like this is kind of a bigger than a liter, yeah, just about a liter. This much gas would get me 100 kilometers, basically. Well, sorry, 8.2 of these would get me 100 kilometers. Okay? So it's really different thinking the way the Canadians put their. And I really, when they tell me 8.2 liters per, I'm like, is that good? Oh, is that good? I don't know. Like I know 20 miles a gallon, that's kind of like, you know, you better do better than that nowadays or you're not going to be able to sell a vehicle, right? Because gas is expensive, right? Now, with this, we have to try and do a couple of composite. We're going to do a composite function. You'll see how this works, okay? So the first thing is, it asks that how many liters would I use if I had to make it in terms of distance? Okay? So the number of liters I would use would be 0.082 times the distance, right? That's the liters of fuel I'll use because it does 0.082, and if you've done the physics, if you've been in physics, right, this is 0.082 liters per kilometer. And if we multiply that by kilometers, okay, you can see we're left with liters, right? Because physics is really good for teaching you unit cancellation. And the units would cancel, and we would be left with liters. That's how many liters I'm going to use. Now, the cost of gasoline is you take the number of liters and multiply it by how much it is per liter, right? So if we take the $1.25 and multiply it by the number of liters. Now, do you see here that this liters and this liters are the same thing, right? So I can take liters, and if I wanted to find out the exact cost by how far I drive, all I have to do is take this, put it in here, and then I could plug in distance. Distance would multiply by the fuel efficiency, which would multiply by how much per liter. So this is $1.25, and you see I'm going to take the L and I'm going to replace it with 0.082D, because 0.082D is the number of liters I would use. So, and then just so you don't get hung up on it, this is just F of D, G, and H. Okay, they're just F, G, H. So one of the other class asks, what does H stand for? And I'm like, no, it's just the using a different function. Okay, and then you could multiply this out, and this would be 0.0, or not 0.0, sorry, 0.1025D. So that's the cost. That's how much it would cost you to drive X kilometers, or D kilometers, right? And do you see how I put a function inside of a function? Okay, I took 0.082 and I put it into where L was. Okay, so that is a composite function. So let's go to the next page at the top. So if I have two functions, to put a function inside of a function, we would call it g of f of x. And do you see how f of x is inside g of x? So that makes sense, right? The part that may be new for you, or a new way of thinking, is this means the same thing, g of f of x. So I always remember that since f of x is second, it goes inside of g of x. Okay, you need a way to remember that g of f of x means that f of x is in the inside. Okay, so it kind of even looks like it's in the inside there. Whatever you need to remember that if they change the order on you. And if you take calculus, you're going to be using the chain rule when you do derivatives. Okay, so we're going to go to the bottom of the next page, because all that other stuff is extremely confusing. I knew what I was doing, and then I read that stuff, and I was so confused, I almost screwed myself up. So thinking, okay, let's stay away from that. Now we've got g of f of x. Now that means that, okay? It means let's put f of x inside of g of x. So here is f of x. I'm going to put it right there. I'm putting f of x inside of g of x. Does that make sense? So what would that look like? 3 bracket 2x squared minus 1 minus 4. And if I wanted, I could call this h of x. Because what I did there, does that make sense? Okay? Now, it's just the math, okay? Because we got to do this. 6x squared minus 3 minus 4. This equals 6x squared minus 7. Okay, g of x. That means take g of x and put it inside g of x. Okay, g of x. Okay, so I'm going to put g of x inside of g of x. So that is 3 bracket 3x minus 4 bracket minus 4. Okay, so that is 9x minus 12 minus 4, 9x minus 16. Okay, now just in case you were understanding this, let's try and do some more confusing stuff. Just in case. Okay. Now I know that looks like fog 2, but that's f of g of 2. Okay? Now, what that is saying is, where does the 2 go? Inside where? It is going to be the x, but where would I put that 2 right now? In the g of x. Okay? So, this would be f of square root 2 minus 1. Is g of 2 inside f of x? Okay. You're going to see how I do this. I'm going to figure out what that is first before I put it into f. But you see how I've got 2 into g of x. Now, square root, that's the square root of 2 minus 1 is 1. What's the square root of 1? So I have f of 1. Everyone get that? Okay. Now, I'm going to put 1 into x squared minus 3. So that would be 1 squared minus 3, and the answer is negative 2. So you can do g of x. Now, some people might be asking, can I put g of x into f of x, solve it, and then put 1 in there? Think you could? Yeah, you can. So you can do the whole equation like we did here, right? And then you could just put 2 in after you're done. F of g of x or g of x or whatever it asks you, okay? Either way works. Okay, f of g is 0. So g of 0, we're going to put that into here first, right? So that's f of square root 0 minus 1. Can't do square root. So f of g of 0 does not exist. Okay, g of f of 2. So we're switching the order a bit. Now we're putting 2 into here. So this is g of 2 squared minus 3. So that would be g of 1. Now I'm taking g of 1 and solving for it. So that would be 1 minus 1. Square root of 0 is 0. Now an interesting question would be, where would I ever use this in life? Okay? I promise you, you will never use this, but you will use this thinking. Okay? So when you get, like, this changes you. I mean, seriously, after you've done questions like this, f of g of 2, and it actually makes sense, right? I get it. It's a function inside of a function, right? There's there's things going on upstairs that you just don't understand, that you understand when people try to tell you how this becomes this and the whole thing, and most people are glazing over, and you're like, no, I get it. Okay, keep going, right? And so you would never use this, but you would use the type of thinking that you need to do this, okay? It's very complex to be able to explain to you what has to happen actually. When you understand this, I mean, Yeah. It gets it, like if you're really good at it, it puts you in areas of strength that if you're not really good at it, you wouldn't be able to do, like in engineering or medicine or things like that, right? Because like when you're in medicine, you really have to think like this. Okay? If you're going to be a doctor, you're just don't walk in. You could probably um, you probably couldn't talk to four people without someone having something right now that the doctors quite can't figure out. Or I'm just messing around with the meds till I can get this or whatever. I'm just getting stomach all the time and they don't know it. There's not a doctor right now that isn't dealing with probably like 100 cases that they can't quite figure out, right? So that's the kind of thinking you need to be in medicine. And yes, you got to be very good at math to be in medicine. There, look at your math mark like crazy. Okay. Now, g of f of 0 means we're going to put 0 into f of x, right? So that would be g of 0 minus 1. So that does not exist either, right? Because you cannot take the square root of negative 1. I screwed that up. Am I backwards? Yeah, I did. Okay, I should put it in f. So that should be g of 0 squared minus 3. Okay, that should be g of negative 3. Now I'm going to put this into negative 3 minus 1. That would be negative 4 does not exist, right? Okay, let's do the domain and range of f. So the domain of f would be what? Okay, let's write it here in case you're x squared minus 3. So is there any restrictions on x? No, x would be in the reals, right? Now, here's where you really have to just start thinking about the range. Now, this is, I'm not even going to show you the graph, but I want you to put, what is the smallest real number we know? We don't know that one, do we? What's the middle real number we know? 0. So they're going to go, if you see how we're going to 0, 1, negative 1. So 0 is kind of the middle real number, right? So if I put in 0 there, what's my answer? No, it exists. 0 squared is 0 minus 3, right? Will you ever get a number smaller than minus 3? You won't, would you? Like if you put negative 1 in there, that becomes squared, so that's 1. 1 minus 3 is negative 2. And if you do see the graph for it, this is a horizontal translation, 3 units down, or vertical translation, 3 units down. This is actually the graph. And do you see how you'll never get anything less than negative 3? So your range would be x is greater or equal to negative 3. Why? Yes. Okay. Now the next one, g of x, is x minus 1. Okay. Now again, I'm not going to draw the graph for you, but I want you to first look at the, how do you figure out the domain? What x's are allowed? All of them? No, not all of them. Negative 4 is not allowed in there. Negative 4 minus 1 is negative 5. There's a lot of numbers that aren't. Well, x minus 1 has to be greater or equal to 0, correct? So therefore, x has to be greater or equal to 1. Because if I add 1 to both sides, right? Why not? Square root of 0 is 0. No, because if you put in 0 there, 0 minus 1 is negative 1. You'd get it wrong. Okay, and now let's think about it. Let's try 1. What would be my answer if I put 1 in there? Because 1 is the smallest number that qualifies in this domain, correct? Everything else, 2, 3, 4. So try 1. 1 gives me the answer what? 0. What does 2 give me? 1. So you see that the y's will be greater or equal to 0. Now, if you do the graph for this one, this is what the graph looks like. Okay? Where x is greater than 1, greater or equal to 1, and y is greater or equal to 0. That's what the graph looks like. Now, the question you may be asking is, can I just graph it and go from there? Well, you're going to start to see where that messes you up too. Now, basically, this question here is this guy named Aaron. He did this question. He got this graph when he did f of g of x, and this graph when he did g of f of x. He did his domain from there and range from there and made the wrong conclusions. So we're supposed to find his errors. Now, when we were doing yesterday's, this graph is very different than this graph. Okay? So what I'm saying is this graph is different than this graph. Now, to most people sitting around a campfire, they'd go, that's ridiculous. You just said x minus 3 is a different graph than x minus 3. But when you get to our level, do you see why those two graphs are different? Why? Yeah, the second one has a non-permissible. We'll have a hole in it at negative 2. Okay? That's kind of what's going on here, and I will show you why. Okay? Now, let's do f of g of x and g of f of x. Okay? So f of g of x would be, if I take g of x and put it into f of x, so that would be the square root of x minus 1 squared minus 3. Okay? This is f of g of x. So I put g of x into f of x. Okay? Does that make sense? Now, let's do the math on it. Let's work sideways on this one. So that goes to x minus 1 minus 3, right? Because when you just get rid of that square root. So this equals x minus 4. Now, Aaron just went and graphed x minus 4, and he got that graph, and he says, hey, x is in the reals. So he just looked at the answer. He ignored everything before it. If you don't ignore everything before it, why is our x minus 4 different than the one he put in? Because we have a restriction. And our restriction is right here. We have to follow that rule. Therefore, what x's am I only allowed in this question? X has to be greater or equal to 1. See, and if you look at Aaron, he concluded that x can be in the reals because he just looked at the final answer. Just like yesterday, x minus 3 is very different than x minus 3 if I got that from canceling a numerator and denominator. Okay? So this is kind of one of those things, just don't look at the end. for your answer, or you will get it wrong. Okay? Now, come on, if you were making a diploma, you'd be all over a question like this, right? Solve it, and what's the domain and range, right? Easy question if you know what you're doing. Even easier if you don't, okay? Because it's fast. You can look at your graph and calculate. You get the wrong answer, right? But both of them, you can walk out of that diploma going, yeah, I got that one right. And then you're sitting talking to people, and you go, but remember how Mr. Tribble said you have to go back and check? And you're like, oh, and why did I leave 45 minutes early? I could have caught that one, okay? And I knew that. You know, it's on my study sheet. I knew that, right? So I want to make all those moments on my quizzes, right, and in the homework and in the notes. So when you get to the diploma, you're like, okay, we did one just like this. I know what I'm doing, okay? That's the goal. Now, I want to actually keep finishing this one because f of g of x, if you come down here, what was the domain? X is greater or equal to 1. Now my question would be, therefore, what would be the range? I want you to put 1 in here. 1, 2, 3, 4. What would be my y's? So what if you put 1 in there? What's your answer? 0 for that part. What would be your answer for? Well, actually, I guess what's even easier, since we have picked that, you can pick your 1 and put it in here. So if you put in 1, what's your answer? -3. If you put in 2, -2, -1. Do you see how, what is the smallest y you'll ever get? So y has to be greater or equal to -3. So there is no exact science to this, but there kind of is, but you got to know how to test it, okay? And you're going to come up with it by thinking, okay? I know we hate that sometimes, right? And that's when it's noisy and someone's like doing something repetitive and we're trying to concentrate, right? This stuff is hard, okay? So that's why I keep it quiet in here when we're doing homework and stuff like that, because some people, they need that, right? Now, I'm going to graph this x minus 4, which is a nice straight line going through 4, but I have to stick with the requirements. X is greater or equal to 1. So here's where it is starting. You see, there's the x is 1. I can't go left of it, and I can't go below that as a... So here's your graph for that one. Those are all the numbers that will work there. See how it's different from Aaron's graph? Because he just did x minus 4. Okay? So I would think it was weird if they didn't put a question like this in the diploma. Okay? One like the one I gave you on the quiz today that has a hole, or this one that has a domain error. And remember, domain and range, domain and range, domain and range. That's what diplomas just stick with it, right? Okay. So does that one make sense? What has a different domain or range than just x minus 4? Okay. Now let's do f or g of f of x. Okay, g of f of x. Okay, so for that one, I'm putting f of x inside of g of x. Okay, so that is going to be the square root of x squared minus 3 minus 1. So I put f of x inside of g of x. So x squared minus 3 went right into... Now, you can just drop the brackets there, and you get the square root of x squared minus 4. Okay, that's x plus 4, x minus 4, right? So I actually can't do any more. I can't take it out. I'm done. The question would be, what is the domain? And this is another tricky one. When you see what I do here, I'm just going to get rid of this line right now because x squared minus 4 has to be greater or equal to 0, right? We get that? That bottom has to be greater than 0. That inside, I should say. So x squared must be greater or equal to 4. Now, from here, this is maybe where you want to stop. Because if you do the square root, you're going to get messed up a little bit. Because two answers come out of this. Now give me the number that you think works here. 2 and negative 2. Now, to be greater than 4, though, let's think of all the positive ones. Would be 2. What would be the next one? Would it be 1 or would it be 3? 3, 4, 5, right? So do we all agree that x has to be greater or equal to 2? That makes sense. Now here's the kicker. X also, we said negative 2 works. What is the next number that works? Does negative 1 work? Negative 3, negative 4. So do we agree that x has to be less than or equal to negative 2? That's, I don't know what to say, but and I even talked to a couple of math teachers, like, what's the math behind it? And they said, well, don't do the math behind it. You can do the thinking behind it. No, because if I did this, I would get this. If I did it algebraically, and again, this is why it's good to listen to the notes live than to see this, but if you did the square root of both sides, right, I'd have to put plus or minus. So then you're going to get x is greater or equal to plus or minus 2. And now that's weird because x isn't supposed to be greater than the negative 2. Remember when we divide negative by both sides, but we didn't really divide negative by both sides, did we? So mathematically, it's actually bad for me to keep going, right? I want to be able to stop and just say x squared is greater or equal to 4, and then from there, pick them. Okay? And you'll know it's always when it's an x squared is greater or equal to. And if you think about it, we've never done those before. It's always been x squared equals. Okay? If x squared equaled 4, I would take the square root of both sides, right? And when you take the square root of both sides, x would equal plus or minus 2. But we never have done them with the inequality signs, okay? Okay, so it's kind of a totally thinking day today, okay? Not really exact math, like it's mathematically correct, don't get me wrong, but I can't give you a next step that would make sense to you if we kept going, okay? Now, I want to actually put that down here. My domain is x is greater or equal to 2, or x is less than or equal to negative 2. Okay. Now, what would be the range? So what I want to do is I want to look at the answer, okay? And I'm going to highlight the answers because right now, that was the first answer. This is the second answer. So what I want to do is I want to find out. So the smallest number greater or equal to 2 is 2, right? What happens if I put 2 in there? What do I get? 0. 3, 4, 5. Is it greater than 0 or less than 0? Greater. So for this one, I will get a range of y is greater or equal to 0. By plugging in 2, 3, 4, 5, 6. Okay? Now let's do the other one. Negative 2, negative 3, negative 4. What does it give me? Does it give me less than zeros? Because if it gave me y is less than or equal to 0, I'm saying y is in the reals. Because I got all greater on that side, and right? So is it going to give me different than y is greater or equal to 0? No. So this one, if I was to graph it, it actually starts here and goes like this. And do you see how I'm different than his? He starts at 1. Because when you just do the final answer, you get that graph. Okay? Now, if you go to the next page, okay, basically it's saying there may be restrictions on the domain and range. That's what we've talked about. Then the next line says, in most cases, domain and range of a composite function will be different from the domain and range of the original function. Okay? Yeah? In most cases, sometimes it won't. So really, that's a waste of words, right? I mean, we didn't really need that, right? And then this one, I caution you to even memorize this, but just so you know, the domain of a composite function f of g cannot be more than the domain of g, and the range of a composite function f of g cannot be more than the range of f. I mean, that's going to take a little while to even digest, and it's memorization. But if you go to here, and all you do is think, you don't have to memorize that thing that you're going to forget anyway. Okay? So it's just thinking. Go through and go, x minus 4. Hey, there's no restrictions on x minus 4. Oh, wait a minute. I should go back through the question and see if there's any restrictions in there because they stay on the question. Okay? This makes sense? Okay, I hope so. And you have the ability to do it all in class, so I'm here to help you on anything that's kind of weird. So you're doing 1, 2, 7, 8, 9, and 10. And then 11, 12, and 13, just do A and C for those. And then the multiple choice, 14 to 16. Okay, just a caution, number 9, the answer for A is B and the answer for B is A. So switch A and B answers, okay? So when you do 9A, look at 9B answers. And when you do 9B, look at 9A answers. Okay? Does that make sense? So you have lots to remember today. Even the answers are messed up.